Before have we seen the Hubble Telescope captures images of a spiral galaxy. By traveling through light and space, James Webb can see the universe's origins, which our minds can only begin to comprehend. The first images shared by this powerful telescope showed us a sight beyond our expectations. I am sure you all are fascinated by the universe and the wonders of space. But have it ever occurred to you what it would be like to see and experience the outer world? So let's get started. The NGC 1961 spiral galaxy has been recorded magnificently by NASA's Hubble Space Telescope. According to studies, NGC 1961 is located approximately 180 million light-years from Earth in the cluster Camelopardalis. Both an active galactic nucleus and an intermediate spiral galaxy have been used to describe it. Several studies show transitional spiral galaxies between barred and unbarred spiral galaxies. They lack any proper stars. At particular wavelengths, the cores of active galactic nucleus galaxies are noticeably brighter than the rest of the galaxy. There is a high likelihood that NGC 1961 has a supermassive black hole at its core, which would eliminate the galaxy's wind and give it a distinctive appearance due to its bright jets. The majestic spiral arms of the galaxy contain reddish regions of active star formation, dazzling blue clusters of massive young stars, and dark dust lanes that conceal them. In the brilliant, yellowish central regions, populations of older, cooler stars are visible. Before we discuss how beautifully the spiral galaxy has been captured, let's discuss the tool that captured the images. Hubble's primary scientific objective was to determine the universe's age and size. To accomplish this, astronomers measure the varying luminosity of Cepheid variable stars, whose varying luminosity follows a regular pattern, the frequency of which is dependent on the star's actual luminosity. Astronomers use this pattern's frequency to determine a galaxy's distance. Hubble's large mirror helped detect Cepheid variable stars at greater distances, confirming the universe's expansion and age. Moreover, this same high resolution enabled observations of even more distant supernovae, proving that the universe's expansion is accelerating. This revolutionized the field of astrophysics and earned the 2011 Nobel Prize in Physics. Many attempts have been made to capture the spiral galaxies, and the prominent captures were Hubble images and James Telescope Webb images. According to the news release, the Webb image shows more of a continuous tangle of structures that echo the spiral arm shape. In contrast, the Hubble image shows dark regions that seem to separate the spiral arms. The images show various stars depending on the wavelengths each telescope can detect. The dusty regions of the galaxy cause the difference in a side-by-side comparison of the images. Dust-rich regions appear darker in Hubble's view because interstellar dust can scatter ultraviolet and visible light. Interstellar dust can be penetrated by Webb's ability to detect infrared light. Together, these two perspectives on the same galaxy shed more light on its structure and composition. Because even slightly warm objects can emit infrared light and distort an image, Webb's instruments must be extremely cold to operate. Only 7 degrees Celsius above absolute zero. The MIRI instrument is maintained at -447 degrees Fahrenheit -266 degrees Celsius. On a thermodynamic scale, absolute zero represents the lowest possible temperature. Webb's near-infrared camera NIRCam can only detect objects between 0.6 and 5 microns in size, so Neptune does not appear blue to him. Except for regions with high-altitude clouds, the planet is quite dark at near-infrared due to the strong absorption of red and infrared light by methane gas. Methane ice clouds are visible as bright streaks and spots that reflect sunlight before it is absorbed by methane gas. The fact that Webb's images differ significantly from those of Hubble is a good thing. The two telescopes utilize different light regimens. While Webb sees in infrared, which can capture light obscured by dust and gas in optical wavelengths, Hubble is primarily an optical and ultraviolet instrument. Because Webb can see the developing stars inside the gas that Hubble picks up, The observations are complementary. We'll see star clusters in the centers of these dense molecular clouds. Before, we only had circumstantial evidence, according to astronomer David Vilker of Johns Hopkins University. The star clusters that have just been put together can be seen in Webb's star factories, and their properties can be measured before they evolve. Comparing the images reveals that Webb still detects the glowing gas but does so with much greater detail. The galactic nuclei appear as a bright, featureless glow in Hubble's images. Still, Webb sees right through them to reveal much more information about what is happening in the region surrounding the supermassive black holes that the galaxies are rotating around. We are at the beginning of a daring new era in space science. Webb already appears to have identified the earliest galaxy to be discovered at a record-breaking distance. On ArXiv, papers are appearing in a flurry. These new photos represent some of the most in-depth infrared views of spiral galaxies we have ever seen. NGC 1961 had previously been depicted by NASA. A picture of a supernova remnant had previously been made public by NASA of the U.S. using Chandra and the Hubble X-ray telescope data. According to the government, scientists used information from the Hubble, Chandra, and Spitzer space telescopes to rewind the star's explosion. They gained knowledge about the star's surroundings before the explosion and how a stellar explosion occurred in the distant past during this process. M74, also referred to as the Phantom Galaxy, was photographed by the James Webb Telescope and made public by NASA this month. The image showed thin filaments of dust and gas in the spiral galaxy arms. Due to the lack of gas, the nuclear star cluster could also be seen clearly. NASA recently released a telescope image that shows two galaxies colliding. These two galaxies are SDSS J115 and Leda 2,073,461, respectively. Despite being so close, these two galaxies do not interact. The picture had previously been uploaded to the telescope's Twitter account. According to NASA, the two galaxies resemble ships sailing across the night sky. Recent Hubble observations, according to NASA officials, show that NGC 1961 is a typical type of active galactic nucleus AGN that emits low-energy charged particles. Astronomers have been able to observe the unprecedented motion and changes in the shapes of stellar jets over time thanks to the Hubble Space Telescope's long lifespan. Stellar jets are produced when gas swirls into young stars, and some of it is then directed by magnetic fields and ejected at supersonic speeds from the poles of the rotating stars. These vigorous jets of glowing gas emitted from young stars can be observed in exquisite detail in the infrared. Understanding the origin of these jets and the environment in which stars are born has benefited greatly from numerous observations made over time. So what's next? Hubble outlived expectations by a significant amount of time thanks to numerous shuttle missions that repaired its worn-out components. However, the telescope will soon be retired as it enters its fourth decade of scientific use. The James Webb Space Telescope JWST and the Wide Field Infrared Survey Telescope WFIRST could come close to replacing this large observatory. However, no single telescope is anticipated to do so. Both telescopes will feature significantly improved camera technology and larger mirrors that can gather more light, similar to leaving a camera shutter open longer, leading to greater depth and detail. Together, they will extend beyond and cover the wavelength range that Hubble operated in. I can't wait for the following generation of space telescopes to outperform Hubble and reveal even more astronomical marvels. That is it for this video today. However, there's nothing to worry about. We have many space-related topics to cover in the coming days, so click the bell icon and subscribe so you don't miss out on any new videos. See you in the next video, fellas.